There are many different ways of sorting lists and then searching through them. This video will look at the selection sort. The selection sort works like this. It looks for the next lowest or highest, depending on the way you're sorting. So from smaller to biggest or from biggest to smallest. So it looks for the next smallest item in the unsorted list, selects that item, and places it as the next item in the sorted list. For my example, I'll be sorting cards, and for cards of the same number, we'll define them like this. Clubs will be smaller than diamonds, which will be smaller than hearts, which will be smaller than spades. So my card class implements the comparable interface, which means you can call compare to on it. And if the first card is smaller than the second one, it will return a negative number. Code for a selection sort could look a bit like this. Keep in mind this is only one version of doing it, and there are many ways possible. It's also possible to sort an array rather than an array list, or to work in a non-destructive manner by making a copy of the original array list given. My example is a helper method, which starts public static array list cards sort array list of cards to sort. So it will return an array list of cards, and it takes an array list of cards called to sort. The first thing it does is create an empty array list of cards called sorted. Then comes a while loop, which says while toSort.size is greater than 0, so while there are still items in toSort. We'll create an integer index smallest, which will start off being 0, and card smallest, which is the first item in toSort. And then we'll have a for loop that starts at int I equals 1. This is a bit unusual, but it's because index smallest is set to 0 and smallest, the card, is also set to the first item. So we don't need to look at the first item in toSort because we've done that already. We only need to look at the rest. So starting at position 1 until the end of toSort, if the card we're currently looking at is smaller than the smallest, so if toSort.getI.compare to the card's smallest is less than 0, the index of smallest gets updated to be I, and the card smallest gets updated to be the card in position I of toSort. Then once that for loop is done, it means we will have found the smallest card in toSort, and we're going to move that card from toSort to sorted. So that goes sorted.add toSort.remove index of smallest. Remove the card at position index of smallest from toSort and add it to the end of sorted. And then this will happen as long as there are still cards in toSort. And when there are no more cards in toSort, they will all have been moved to sorted, and you can return the array list sorted. So let's run through an example of this. We'll start with an array list of cards to sort, which is filled with random cards, and we'll create an empty array list called sorted. Now inside the while loop, we'll create our index of smallest and our card reference smallest. Index of smallest with the value of 0 and smallest pointing to the first card in toSort. Then in the for loop, we'll look to see if we can find a smaller card. So first we'll look at the 6 of diamonds, which is indeed smaller than the king of hearts. So we'll change index of smallest to 1, and smallest will now point to that 6 of diamonds. Now we'll keep looking down the row. The 9 of spades isn't smaller than the 6, so we keep looking. The 2 kings aren't smaller than the 6 either, so we can overlook those. The 7 of hearts isn't smaller either, but the 3 of diamonds is. Index of smallest will now go to 6, and smallest will point to the 3 of diamonds. So now we'll move that 3 of diamonds to the sorted list, and then reset smallest and index of smallest to be pointing to the first card in toSort, so the king of hearts. And then we'll do the same thing again. We'll look through toSort looking for the smallest card. So the 6 of diamonds is smaller than the king of hearts, so we'll change smallest to be pointing to the 6 of diamond and index of smallest to 1. And then as we look through the rest of the list, none of the other cards are smaller than the 6 of diamonds. So we can move the 6 of diamonds to the sorted list, and reset both smallest and index of smallest. Since we've removed the 6 of diamonds, that means the rest of the list all shuffles down to fill the gap that's been left. Smallest and index of smallest start again at the first card of to sort, which is the king of hearts. And we find that the 9 of spades is smaller than the king. So the index of smallest goes to 1, and smallest points to the 9 of spades. And then as we go down through the list, we see that the 7 of hearts is smaller than the 9 of spades. So index of smallest becomes 4, and smallest points to the 7. And since there are no more cards left afterwards in to sort, we can move the 7 to sorted and reset smallest and index of smallest. And then we start again. We find that the 9 of spades is smaller than the king of hearts, and both of the kings afterwards are bigger than the 9 of spades, so we can move the 9 of spades to the end of the sorted list and reset smallest and index of smallest. The 2 kings shuffle down to fill in the gap. So here we see that the king of diamonds is smaller than the king of hearts, so that becomes the smallest card. But the king of clubs is smaller than the king of diamonds, according to the rule we defined earlier. So the king of clubs gets selected to go to the end of the sorted list. And we start again. Now the card we find to be the smallest is the king of diamonds, so we move that to the end of the sorted list. And now only 1 card is left in to sort, so of course that's going to be the smallest card. And the king of hearts gets moved to the end of sorted. And there we go. We're done.